this picture. Okay, I actually made this picture, I think, sometime in the beginning of 2024, something. So, it's kind of a 1 year missing. So quite a lot of good things I didn't include because really so sorry about that. Too busy. I haven't completed that. But anyway, I think it's still a very good, kind of a comprehensive review of the AI development. So artificial intelligence. So I'm sure, most of you should be quite familiar. This word, artificial intelligence, was actually developed in the Dartmouth conference in US, right? 1956. But however, I'm not sure because I guess most of you are quite young, should be quite young people there. So actually, AI kept silent for so many years. So there's kind of a boom, or people feel excited in the 1990s something because there is so-called a deep blue, kind of supercomputer, but nowadays it's just a very simple algorithm, right? Knowledge-based based algorithm. And but anyway, Deep Blue is the first, moment that actually the computer beats in the Jeopardy game, right? Beats the person who is kind of best worldwide. So people just realize, wow, it's so fantastic. But however, after that moment, actually, we think that AI kept silent again for so many years until probably in the late 2000 something, before 2010 something. But actually, because I have been working with industry after my graduation for almost 15 years, and in my opinion, to be honest, so every technology, the bloom or the successful or popularity of any technology should be accompanied, with some very important business or very important production. For example, we have to say that AI or the CN-based models, we really have to appreciate the boom of the internet services because we know though there's so many different applications from the internet-based or what we call also Web 2 based, right? Because it's centralized. For example, like e-commerce, Taobao, right? And Amazon as well, similarly, right? And also, for example, like the like social media, TikTok, right? ByteDance, though they're kind of suffering nowadays. But anyway, it's still Web 2 based. There are so many different applications. And in my opinion, there are three core technologies. Though there's various, different applications, but three core technologies behind all these internet services, search, right? Recommendation, and also computational advertisement. And indeed, CNN-based models, backbone model is CNN, though there's kind of many different variations like RNN and RSTM, but it doesn't matter. The back model is still very similar to CNN-based models. And indeed, CNN-based models helped the internet service, internet business, right? Web-based services, create quite a lot of money. So this is indeed a very successful technology and successful business, and especially very important because the boom of the internet services, we have so much huge amount of data. In that sense, we can learn CN-based models. Without that huge amount of data, actually, we cannot really to train a huge, in that days, kind of a big CN-based models. And after that, actually, till actually, to be honest, till 2020 something, even Transformer was released in 2017, and we actually know. I'm not sure how many you actually go back to read that, the history. But actually, GPT-1 and the GPT-2, we have to say, is not that successful, and especially BERT. And the following is called Roberta. They actually perform very well, especially what I just said. They become very successful, especially in the search-based engine. But BERT or Roberta, they were quite small. I think the largest size of BERT is only 34 million. Yes, 34 million size of the parameters, much smaller compared to GPT-3, because even much smaller compared to GPT-2 as well. So, but anyway, to be honest, I think, around 2020 something, both in US and as well as in China as well, the internet services, people kind of felt in a situation, because I have been working with IT companies during that time. We're actually trying to cut some cost. Yes, so but do not want to invest much more, but still keep the performances, online performances. So that's around the 2020 something. And actually, only after GPT-3 was released, it's actually much larger. So it's like a 175 billion size of the parameter, much larger. We never even imagined that size of the models. But actually, the beauty of GPT-3 is that so-called zero-shot performances, right? So people find, oh, we do not have to really fine tune. But still, we know nowadays if you really want to do very well to some specific tasks, you still have to undergo the fine tune and probably RL or the DPO direct preference optimization in the later on stages. But anyway, because GPT-3, when it was first released, some of the tasks you can do the so-called zero-shot performances, and it performed really very well. But I have really to point out that actually. Transformer, especially the GPT series models, they actually are very experienced with so-called generation capabilities. But however, if you care about like representation or classification, BERT-based or RoBERTa-based models, they still perform better. So if you go back to see the GPT-3 paper, you will see that actually, though GPT-3 is like probably 100 times or even larger compared to RoBERTa, but still, for some traditional NLP task like representation classification, RoBERTa still perform much better, or at least significantly better compared to GPT-3, right? So even at those time, people still are kind of trying to figure out which modeling structure will be the best in the future, right? People are not sure during those time. Even GPT-3 was released. And actually, let me just summarize. During those time, there are actually three very popular modeling structure. One is so-called bidirectional, right? BERT and RoBERTa, they are representative. And the GPT-3 and following around GPT 3.5, GPT-4, they are decoder-based. Actually, there's one model, so-called the T5 model. Probably, you guys don't quite remember, but that model actually, in theory, in the modeling perspective, in my opinion, probably is the most flexible one because it's encoder plus decoder. But we have to say, indeed, it's very hard to train. And especially, T5 or RoBERTa or BERT, no one really scale up to 175 billion size of the parameter. So to be honest, is decoder the best modeling structure? Is really very hard to say because really no one make a fair comparison. But I think we have to appreciate OpenAI is that they are actually work very hard. Their philosophy is so-called scaling up. The emergent capabilities only appear, because of the scaling of the size. And after that, I guess you guys should be quite familiar with all the, different, outputs of the, various productions of the OpenAI. For example, like you can consider that the text base. So in my opinion, nowadays, there are three levels of the, modeling capabilities of the Gen AI models. The first level is so-called chatting and memorization. And consider, the OpenAI's production is actually GPT-4. And the second level is actually harder. It's so-called reasoning and planning. So you can consider GPT-4o actually tackles the reasoning problem, not yet planning problems, because planning, we're actually, if you consider like embodied AI or robotics, we are still far less with the data compared to like reasoning or just the chatting or memorization. So planning is still a long way to go. So the third level of the capabilities, in my opinion, will be the multimodal large language models. Then it will be GPT-5, right? Okay. So yeah, that's a kind of a very brief introduction or summarization of the AI history. So indeed, there's a huge opportunities for the so-called enterprise Gen AI. So as what I just summarized, we actually in the AI scenario, we probably call the last generation of AI with the model backbone of CNN-based models, right? And we know that models with the CNN-based backbone, they actually only have the capability of representation, not the representation of generative AI, right? And now because of the the Gen AI models, we actually see there's so many more new opportunities we can probably explore in the future because the previous models they don't have this so-called generative capabilities, and especially ultimately its philosophy is text to all generation, right? Text to text generation, text to image generation, text to video generation, text to audio generation, everything, right? So the imagination will be infinite. So it's kind of a new opportunities should arise there. But I still want to emphasize a little bit here. I think we are still currently, we are still struggling. What kind of a real big, huge opportunities will there be actually? Because you know what? In my opinion, because I have been working with the so-called Web2 based, as what I just described. Search engine and recommendation system, computational advertisement, right? Every applications nowadays you actually use that you can consider is actually Web2 based applications. To be honest, I don't think that Gen AI models will be the huge opportunities will arise with the current so-called Web2 based applications because to be honest, I don't think that the current search engine, the current recommender system, or the current computational advertisement system, they indeed need the representation. They indeed need the generation capability. Because otherwise, if the production itself can be changed, for example, like the user interactive production, for example, like the recommender system, nowadays they never ask us, right, what kind of production you really want. They just use an indirect way based on your click, your impression, and your conversion to make the recommendation to yourself, right? The recommender system never ask you what you want, right? So if the production itself never changed, to be honest, I don't think the generative AI will play a very big role there because with representation capabilities, they can perform very well. But actually, but anyway, we still can find that people are still struggling with these big opportunities. But what's the new production with? There's so many possibilities. For example, like AI PC, right? Microsoft, they're working very hard with it, like AI phone, Apple, right, and Google as well, and like AI glass, right, Meta. Probably you guys already bought some of the glasses. So definitely, the Gen AI or the small language model, multimodal small language models that can be launched with various devices should definitely will be a possibility. So that's one possible. Another possibility, to be honest, I think it should be probably some connection with the scientific areas. For example, large language models for healthcare, large language models for energy. So the reason behind that, so we'll actually detail some, some detailed information in the later on during the modeling section. But anyway, I want to introduce a little bit here to help us warm up. So I guess you should be familiar that there are two stages or two paradigm, right? The main dominant paradigm for the large language models or multimodal large language models nowadays. The first stage is so-called pre-training stage, and the second stage is called the alignment stage. And the alignment stage consists of a supervised fine-tuning and reinforcement learning with human feedback, right? And actually, a majority of the GPU resources were consumed during the pre-training stage. So during the pre-training stage, nowadays is probably very popular. You actually prepare like over 10 trillion data or around probably 20 trillion data, that huge amount of data, right? So in this stage, actually, the philosophy is that you want to memorize all the so-called knowledge point, worldwide knowledge, right? So that's the reason what we call pre-training stage. And the second stage, for example, like supervised fine-tuning or DPO, direct preference mode optimization, which is a popular alternative of the complete reinforcement learning nowadays, it's actually labeled data. For example, supervised data is positive supervised data, right? And the DPO, direct preference optimization, is pairwise ranking. It's probably very likely a negative sample paired with a positive sample. You can do some pairwise ranking. So what does this part mean? And here, this labeled sample, both for supervised fine-tuning and plus DPO, you probably only need like a few millions, sampled labeled data. So, well, remember what I just said, during the pre-training stage, you need like a few 10 trillion data, probably 20 trillion data, right? But in the alignment stage, you only need probably 1 million or 2 million labeled data. Supervised fine-tuning, actually, you tell your large language models what you should do. And the DPO, actually, you tell large language models what you shouldn't do. And 1 million or 2 million data, labeled data, is actually just the rules, right, for 1 million or 2 million knowledge points. But, large language model can, generalize to all the knowledge points it memorized in the pre-training stage. Okay, so I hope that I make this whole point relatively clear to you guys. Then it comes the challenge here. For example, So currently, all the so-called open source models are actually fake open source models because they only release the model checkpoint and the infrastructure. What does that mean? That means you can only do fine tuning. You probably cannot do DPO as well. You have to develop some algorithm yourself, and then you can do some DPO. So nowadays, you can only do supervised fine tuning. That means you can only tell your large language model rules, what you can do, what you wish your large language models to perform, and you wish your large language models shouldn't perform, right? But however, for those scientific knowledge, for those enterprise-specific knowledge, you cannot infill into your large language models. So that's possible if we can really make some, large language models can infill all those scientific knowledge in the best way. We probably can indeed make some breakthroughs. Okay. Yeah, so this is kind of a tracking record that I summarized during my past experiences. So because as I just mentioned, we started working with large language models dated back in by the end of 2019, right? So you can tell 2021 to 2022, actually with Alibaba, we actually released two very representative models in China, actually. One is M6 and the other is OFA. So they are very representative multimodal large language models during those days. And after actually, I joined ByteDance in the middle of 2022. And during 2023 till 2024, we actually still working with large, huge foundation models. But even during those time, my team and myself, we actually started to think about one thing. Do we really need that 1.6 trillion cloud-based because we know GPT-4, when it was first released, it was 1.6 trillion parameter size, right? Nowadays, I think GPT-4 is much smaller after various distillation. But again, they are still scaling up, right? But during those time, we are actually thinking, do we really need that cloud-based huge model to serve everywhere, right? Though it's indeed, if you want to achieve so-called AGI, you have to undergo that way. But actually, if you are really just tackling a specific problem or a specific application, and especially the latency or the speed comes quite a lot. For example, your own devices, you carry out with yourself, and you probably can go to some countryside with very bad Wi-Fi internet. In those days, if during those scenarios, how can it perform very well? It's very hard, actually. So we actually started working with so-called small language models, but no, those days, this term hasn't appeared yet. But nowadays, small language model, I think, just very recently, MIT Tech Review, they released kind of a 10 most important AI trending this year, 2025, and SLM, small language model, ranked the first, right? But those days, there's no such term. But anyway, we actually started working with so-called small language models. And especially we found, because for Alibaba and ByteDance, their so-called application ecosystem were really so diversified, and we actually encounter so many various, challenging different applications. But we found actually for every application, even they are quite diversified with each other, probably with only like 7B, yes, much smaller compared to 1.6 trillion, and 13B for multimodal large language models, we can actually beat OpenAI's results in that specific domain. Yes, I mean that specific domain. We're not talking about AGI, right? AGI is very hard. We cannot do that, right? But for that specific domain, we can achieve that, but with two very strong requirements. One strong requirement is that for that specific domain, you have to have your high quality, sufficient domain specific data. That's very, very important. And especially if those data cannot be crawled from the general web, or the distribution is quite different from the IT-based data, then indeed, if you core, I'm sure many of you probably encounter such situation when you do some experiments calling API services, or especially scientific application with GPT-4 directly. It probably cannot satisfy your complex needs, right? So this is very first important requirement. The second important requirement is that you have to do continued pre-train. Remember, as what I just mentioned, pre-training stage, memorize everything, right? That's the stage requirement. In the second stage, alignment stage, is so-called preference alignment. You only need like 1 million or 2 million labeled samples, or pairwise ranking samples to tell your large language models what you should do, what you shouldn't do, right? So they are rule-based, but knowledge infilling has to happen in the in the pre-training stage, right? So you have to undergo the so-called continued pre-training stage. So in that sense, with those two strong requirements, we indeed found that 7B model can satisfy many requirements, that many various applications. That means you can probably beat GPT-4 and GPT-4 in that specific application. And actually, sometimes it's kind of easy, especially your data cannot be crawled from the general web. Okay, and later on, I think by the end of last year, Meta and MIT, they collaborated one paper, and in theory, they actually verified that one parameter can store 2-bit information, and they actually calculate 7B model can sufficiently install all English domain textbook and knowledge, right? Well, for any of our application, the information cannot be as much compared to English domain, right? So 7B model is really sufficient to satisfy a specific domain. I still want to emphasize that a little bit. Okay. Then, yeah, we actually talk about what we have done before. And I guess some of you guys are very, very familiar with that. And still, I hope that I deliver that message to you guys very clearly that if you really want to have your domain-specific data, domain-specific small language model, you have to undergo the so-called continued pre-train stages besides only the fine-tuning. Because fine-tuning, you cannot infill your knowledge. So that's very important message I want to emphasize many more times. Yeah. So, well, let's see. What will be the next biggest things for generative AI? Probably, I don't think I can, foresee successfully for probably next 2 or 3 years, but at least for this year or probably next 2 years, next year, this year and next year. I think it should hold because Gen AI really it persists so fast. We cannot predict anything successfully in the next 3 years, right? Okay, so first, definitely, small language models will become dominant, and it can be used widely in the various enterprise applications and be combined with various devices. Okay, the next thing I feel more passionate or more exciting is that so-called a new machine learning paradigm. So what does that mean? So let's see. So we can actually abstract, the problem of large language model as a mathematical expression. So, or any, machine learning problems. So what does that mean? So given kind of a word knowledge or word data, so what's the goal or motivation of large language models? It's actually you want to estimate the parameters of a function, and you hope that function can represent or, the data distribution that were given to you, right? So that's actually the kind of a mathematical formulation of any, large language modeling problem or any actually machine learning problem. Then how shall we estimate all those parameters, right? We can use so-called MLE or SGD or any other optimization algorithm that currently still holds for when we do the optimization algorithm, when we update, though there's some minor modifications, right? And do some parallel computing. Okay. So in that sense, we actually optimize our objective function or minimize our loss for that objective function over all the data, right? So that's the so-called centralized machine learning, centralized large language models. So in that sense, because of this machine learning paradigm, because we have to maximize our objective function over all the raw data, so we have to cluster our data, our GPU resources in one place. So that's actually a really big barrier so that people can really join this game, right? Because only those tech giants, they have that much money to buy like a few hundred thousands of GPU cards to run that, huge models. For labs, probably we can only buy a few tens or a few hundred GPU cards, right? So it's very hard. But is that the only way that we can achieve the so-called large language models? We believe that's probably not the only way. Then we actually the so-called decentralized large language models. So what does that mean? So actually, we can consider if we can divide the large language, the word knowledge into a few hundred different domains and probably a few thousand different domains. It doesn't matter, right? And I actually have already, delivered that message very clearly. For that specific domain, you can actually beat GPT-4 and the GPT-4o with that too strong requirement, right? You have your own domain data, and you have to do the continued pre-train to infill your domain knowledge into the your domain small language model, right? So that's very too strong requirement. So especially actually, I think another chances exist here because most of the companies who have been constructing large language models, most of the people are actually CS background, computer scientist background, right? But however, for example, I don't know how to process material, material intelligence data. I don't know how to process healthcare data. I really don't know, right? But however, those domain experts cannot be involved. So how shall we process those data? We actually process those data in the same way or other left data. But however, for those scientific areas, how you process your data actually really counts quite a lot, right? So indeed, so as what I just said, in that specific domain, if given the opportunity or given the infrastructure to enable those scientific areas to pre-train their own domain-specific small language models, they really can beat OpenAI's results in that specific domain. Really, they can achieve that. Okay, then given that for the few hundred or a few thousand different domains, we can identify those domain-specific small language models for every domain. And if they can beat probably OpenAI's results in that specific domain, then our foundation model, we probably can just merge or fuse based on all those different models. So the new machine learning paradigm will be model over models, right? It will be not model over data. So to give you an illustrative example here, so the currently dominant machine learning paradigm is actually like a people, right? You give an infinite number of GPU computing power. They actually started to learn the word knowledge, but from the raw data, right? But however, our new machine learning paradigm is like we divide the word knowledge into a few hundred or few thousand different domains. Each domain is represented by that domain-specific small language model that can also be considered as a textbook for that specific domain, right? So actually, we don't need to learn from the raw data. We learn from the textbook itself. In that sense, it's much more efficient. So that's actually why this process is very efficient. So besides that, actually, I'm not sure how many have you been working with pre-training. So indeed, very few people worldwide have been really be involved in the pre-training stage because of the the computing monopoly, right? We cannot involve by that. But anyway, I can tell you the data mixing is very, very critical for the pre-training stage. But however, is if we follow what I just described over the so-called model over model machine learning paradigm, data mixing will not be that sensitive because each model is more robust and represent one domain, right? And but indeed, nowadays we found that actually you can give the weights for the different domain, but however, it's much more easier and much more robust to give the domain-specific weights instead of giving some weights to some individual data, right? So that's much easier. So yeah, so that's the second very important, actually what I believe should be definitely will be probably the next kind of a big thing for large language models. And to give you another, my thoughts here. So I believe actually all the tech breakthroughs should happen that everything clustered together. But however, if you want this technology to be popularized or distribute to the worldwide, actually, then in that sense, it has to be decentralized. For example, not sure if you heard about IBM previously on this so-called mainframe, but still nowadays they have the mainframe, right? It's huge computing, centralized computing. But nowadays, for example, every one of us use cell phone. It's a decentralized, small computing, right? We can contribute. So yeah, so that's the way how I thought about this problem. Okay, yes. So yeah, so currently, not only for scientific challenges, but also for the enterprise solutions. So how shall we benefit from large language models? Currently, we only have two options. The first option is that you have to call the so-called API services, right? There's so many API services there. But however, as what I just mentioned, if your domain knowledge, cannot be crawled from the general web, or your data is very different from the general, web-based data distribution, I think many scientists face such challenges that it not perform very well, right? So, but this is one very popular API solutions. So another solution is actually, as what I just said, currently, there's so-called open source models, but those open source models are not real open source models because they only open source the model checkpoint and infrastructure. So in that means, as what I just said, you actually give some rules, positive rules or pairwise rules. You tell your large language models what you should do and what you shouldn't do, right? But you cannot infill your knowledge. So if you cannot infill your knowledge, how can you solve that problem but still benefit from the so-called open source problems? You actually build an external knowledge base, right? And based on that knowledge base, you build the RAG, retrieval augmented generation, via the open source, the large language models. Then you actually summarize or generate results you want from the knowledge base, right? So that's kind of two currently solutions if we want to use our domain-specific large language models. Yes. Yeah, so this is actually what I just talked about, the new machine learning paradigm compared to OpenAI, right? So two things we want to finish. The first is actually a continued pre-trained infrastructure. As what I just said, this continued pre-trained infrastructure, we're not working on a so-called foundation model, but this continued pre-trained infrastructure to enable every scientific areas to build their own domain-specific large language models. So in that sense, because we have been working with pre-training for so many years, and we know how to build a continued pre-trained infrastructure. So in that sense, actually, those domain experts can prepare their own data, and then this own data will be mixed from the general data when we pre-train the general foundation model, and then do the data mixing. And then we finish the continued pre-train stages. And after that, you still can, prepare the supervised fine-tuning and, DPO data for our own specific domain. After that, you will have your specific domain large language models. So it's definitely much better compared to core API services, or use the RAG-based solutions, because you have your own domain large language model. So that's very different. You infill your knowledge into your domain large language models. The second is actually, for example, many disciplines, you probably can have various downstream tasks, and for each specific task, you probably can have some, domain small language models. And for example, like this, like scientific areas, we have like medicine, healthcare, right? And probably energy. So we can pre-train, have every domain specific small language models. Then we can merge the few tens or a few hundred scientific domain small language models to have this so-called scientific foundation model by merging the various domain small language models, but with rather little GPU resources. Yes, so this is quite different. But the beauty of this whole thing is actually, first, it will include many, many more people to really join this procedure to build something, right? Because currently, not many people can really join in. They can probably only do fine-tuning, but fine-tuning really, you cannot change many things, right? So the capability is actually decided, or the knowledge, right? How much knowledge you infill is actually decided by the pre-training stage. So the second is actually, we want to really democratize this. Many more people can be involved in. The second is actually the GPU resources. You don't need like 10,000 GPU resources to be clustered in one place, but you probably only need like 32 GPU cards to finish this so-called continued pre-train stages, right? Or for 3B model, or 64 GPU cards for like 7B model. That can be affordable by many, many labs, right? So in that sense, not only many people can be involved in, but also we really can have some real domain-specific large language models by domain expertise, right? And also we don't have that strong requirement for the GPU clusters or any computing clusters, right? So yeah, so and also the fusion or the merging model over models procedure, the GPU resources is not that much either. Yeah. So yeah, if you guys interested in, we actually also interviewed by Bloomberg talking about about this co-generative, collaborative generative AI in our opinion. Yeah. So this is actually how we build this so-called small language model via this so-called continuous pre-training paradigm. Yeah, so probably we do not need to go into details here. It follows everything, every other tech giant. As long as we target as small language models. We are not talking about huge models that target AGI. We're actually talking about 7B model probably, right, for large language models, and 13B models for multimodal large language models. So yeah, there's actually critical points you want to do very well if you want to be successful with the pre-training stages. This first is definitely how you process your data. Yeah, I know, I think everyone here is probably either pursuing your PhD or you already got your PhD. I know processing data is not fancy or not attractive to PhD level students or PhD graduates, but I have to say, large language models, how you process your data is very, very important. So nowadays, you can consider AI should be data-centric, not model-centric. Yeah, okay. So the second is actually how you mix your data, as what I just mentioned, right? So mixing your data actually help you balance your various downstream tasks, because you give the more weight to one sources of the data, it probably harm the other sources, of the capabilities, right? So data mixing is very, very critical. How you balance your various dimension of the capabilities. The third is a very strong continuous pre-training infrastructure. Yes, so that's actually what we are already kind of finished. Yeah, so yeah. Also, besides that, I also want to give you a quick look at how much money you can save if you train, not only because you can do a better job to get a better results, but the saving is also significant as well. This is actually I took an example for medium-sized companies, and every day they use like 1 million API cores. Is very regular, right? Very common. And annual expenses can be like $730K US dollars. But however, if you continue to train on the 7B models, and because this is actually for enterprise, so they're actually continue portraying frequency is much higher because they have every day they have accumulated new data, right? But for scientific areas, you're probably not that fast. But anyway, if for a company, they actually first the initial point, get their domain-specific data to get a domain-specific small language models, and after 1 month they continue portraying because they have new data after that 1 month. And every year they only need like 220,000 US dollars something. So it's much cheaper compared to core API services directly. Yes. And also, compared to other solutions that currently enterprise or scientific applications you use, right? I've already talked about that. One is API cores, the other is open source plus RAG, and the third is actually the solution we actually supply. So personalization, if you core API services, actually you have no personalization at all. You have to share your data, right? To those API servers. And open source plus RAG, indeed, because you build up your internal in-house, right, knowledge base. So it's actually indeed you help protect your data privacy. And ours, yes, definitely, because you infuse your knowledge into your large language models. So regarding latency, so API is actually sometimes not that tolerable, especially it's cloud-based, right? So it's kind of high. Open source RAG, right? The most challenging problem for RAG is actually it's very time-consuming. So it's not affordable. But however, our models is local launched. You can actually launch to your own computer, to your own devices. So the latency is rather low. The speed is very fast, right? So performance. So as what I just described. So if your knowledge, your data cannot be crawled from the general web, or the distribution is very different from the general web, very likely it performs very bad, right? But however, if your distribution kind of consistent with the general web data, then it performs very well, right? That's true for sure. And also, for RAG, because open source plus RAG is a two-stage, not end-to-end solution. So sometimes it doesn't perform as what you wish. But for our, because it's a learning process, so you can infuse knowledge. So definitely it should perform well, right? And also it's self-adapting as well because you accumulate your data. And open source plus RAG is also self-adapting as well. But however, because you have your more and more data, that means your knowledge base becomes much larger and much larger, right? So RAG already, what I said, is already time consuming, so it cannot be affordable. Yeah. So yeah, so this is actually based on our continued procurement infrastructure, as what I just mentioned, and we're also focused on the so-called reasoning capabilities, because as what I said, if you really want to tackle some complex jobs in reality, the reasoning capability is very important. So this is actually what we already finished just like 10 days ago, so very recently. So we compared with Llama 3.2 1B model. It's a very strong model, right? So based on the reasoning capabilities include like math, coding, and text-based reasoning, right? So indeed, it has its own advantages. And now we are trying to scaling up as well, and as well as multimodal large language models as well. Yeah. So yeah, so this is some works regarding the so-called decentralized large language models, model over models. So if you guys interested in, actually listed some references here. So indeed, there's actually a unicorn called Sakana.ai. So if you guys interested in, you can actually look into, yeah, I listed here, Sakana.ai. So it was actually built or funded by David Ha. And David Ha is actually one of the authors of the transformer paper, right? The foundation modeling paper of the Gen AI models. And actually, David Ha was also a long-term evolutional algorithm expert. So they actually adopt the evolutional algorithm. But however, because of the evolutional algorithm itself, it actually requires that your model backbone, your domain-specific model, or the model to be merged, your model backbone has to share the same model backbone, as well as the same model size. For example, in their tech release paper, they actually merge a coding model that was fine-tuned on Llama 3.1 and a math model also fine-tuned on Llama 3.1 with the same size 7B, right? But however, indeed, there are so many different pre-trained models with various backbones, for example, like DeepSeek, Llama, right, for sure, and also Tianwen, right, from Alibaba. So they are also very strong, pre-trained models. And especially you can have various model sizes. So if you rely on this evolutionary algorithm, it's not that flexible. So we're actually targeting at our domain-specific small language models can have various model backbones and various model sizes. So we actually go through the so-called fusion algorithm. So yeah, I will not actually, because of the time limitation today, so I will not go into details regarding the fusion algorithm. So this is actually, again, it's different from knowledge distillation. So knowledge distillation is actually a teacher-student, right? So you actually distill your student model from your teacher comprehensive model. But for the fusion, it's actually not that way. So in that sense, actually, our domain-specific model to be fused to get our foundation model is actually just a part of, or the proportion, not the comprehensive way. So it's kind of a, conflict with the, what's the definition of knowledge distillation. So it's not knowledge distillation. So yes, so actually, if you're interested, you can look at these papers, but actually we'll release a paper in the middle of next month or the middle of February. And we believe that paper probably give us really some very promising results, because indeed this problem itself is very hard. So we can just understand intuitively in this way. So again, remember at the very beginning. So we can abstract this problem as a mathematical representation, right? So we need to estimate the parameters of a function, right? So that's actually what we try to achieve. And that function needs to represent the data distribution, right? Okay, so in that sense, what's the problem? The model merging or the model fusion needs to solve. It's actually given a series of the different functions with the different parameters, right? Represent the different small language models. And what we try to achieve is that based on those functions or based on the parameters, we have to project, and also it's a learning process. So we also need the GPU processes as well. So it's not like a mixing or it's learning. We need based on the parameters themselves, based on given some various downstream tasks. So it's also should be a representative data. And then we learn the foundation modeling parameters. So in that sense, you can consider we have a various P1, up to Pn. If we have n submodels, domain-specific models, and P1 up to Pn, they actually represent the parameters, right? So in that sense, you project that P1 to Pn to get a P prime, something like that. So you can consider, you can imagine, especially that P is huge. So in that sense, it's very hard to learn. But we actually indeed identify some very, very promising way. And especially in the middle of next month's release, we can actually learn simultaneously P1 up to Pn to get the estimation of P itself, the P prime itself. Yeah, so that's very promising because it's very time efficient. Okay, so yeah, so what we are trying to deliver is so-called a world-leading decentralized Gen AI models. So as what I just described, so our infrastructure here, we actually can produce very efficient continuous pre-train infrastructure to enable every areas to have their own domain-specific large language models. And above that, based on the model merging or model fusion technology, we can have our own foundation model. Then it can be supplied, launched to the various applications. Yeah. And this is actually summarize what we have released so far. So the first is actually is infusion-based models. We've already talked about that, right? Fusion-based models. And this model is actually, we actually showed the results for the reasoning, for the large language models regarding reasoning. This is actually a multimodal large language modeling targeting at a reasoning problem. So it's actually specific target as so-called GUI, the operation system. So what does that mean? So remember, if you use your cell phone to book a flight ticket, so this problem itself can be abstracted as a so-called multi-image, multimodal large language modeling reasoning problem. So what does that mean? Because when you book a flight ticket, you touch your screen and your screen jump to another screen, next screen, and then the third screen follow on, and then finally you convert it or you left, right? So this procedure itself can be represented by the so-called multi-image, multimodal large language model reasoning problem. So even GPT-4o actually, because this is really very hard and the practical problems, and they can only achieve like 30% accuracy. And we actually only use like a 2B model, much smaller, right? So it can be performed relatively comparable to GPT-4o in such complex real problems. Yes, and also as what I just shared, we want to release very strong large language models and multimodal large language models, but with rather small size, 1 to 3 billion size, especially targeting at reasoning capabilities. And in the middle of next month, we want to release that so-called unified fusion structure, which will be really efficient to help us merge the various downstream domain-specific small language models to get foundation models for some specific areas, or ultimately for the world knowledge foundation model. Yes. Well, yeah, we have some collaboration within our universities as well to support various, the scientific areas. So yeah, so as what I said, we are still, regarding the generative AI technology, we are currently still looking for real new opportunities. And myself, I do believe it should be combined with some scientific areas, not this current, internet services, internet companies. I don't think so. Not the Web2 based services. For example, large language modeling for healthcare. So I'm not sure if you noticed on the 8th of January this year, Nature in one day published 3 papers for large language models that can be applied to medicine and healthcare. So indeed, it's very promising. Yeah. Yeah, so this is now, right? Centralize everything, but probably in the future, it's just decentralized and to support various scientific applications. Yeah, that's my talk for today. Thanks, everyone.
Wow, bravo. Actually, I can feel your passion and enthusiasm for the research and so good. And I have 2 questions about
Mhm.
the actually because we are in Harvard Medical School and we want to train some vision language models, but in the medical images about the data privacy, we cannot share data to others.
Mm,
So yeah, and at the beginning, we want to train a Gen AI, a very big foundation model to include all the aspects, for example, radiology, pathology, something like that. But we found that it's very, very difficult. So now we are in the same way, train some small language models or vision language models. And then that means it can performance very well in the specific area, because in the medical data, it is very difficult compared to the natural language. For example, it is more complexity. There have some spatial words, some spatial expression, something like that. And we found that the small language model can perform as well, but we are confused that how to compare to the foundation model. But after this presentation, we can know that maybe in the next step, we can using the model over model rather than the model over data. That because we share model parameters, it is okay. Yeah, it's
Uh-huh.
very, very good about that.
Okay, cool. Yeah.
Yeah, maybe we can have more. We keep in touch. Maybe in the future we have something about the how to merge models. Yeah, my second question is about that. For example, if we want to use model over model, we have a lot of some small models. How to effectively
Yeah.
merge models is very important, but I think
It's actually very hard. It's also very
very
hard as
tricky.
well.
Yeah.
So yeah, as what I just described, you
Mhm.
can look at papers because we're already running out of time. So, but indeed, it's very hard. So currently, we adopt the so-called fusion algorithm. It's actually it's learning process. You still have to following to prepare some task specific data and it's labeled data as well. Then you actually to learn this. To learn this process. But however, as what I just mentioned, currently it's kind of like a pairwise ranking, pairwise learning. What does that mean? For example, if you have three specific domain model, then in that sense, you have to merge A and B model first, and then B and C model first, and then ultimately this together. So it's very sensitive to what kind of a pivotal models you choose. But however, in our next month's release, so actually, I will share you guys or you can just follow my Google Scholar. We do not have to rely on selection of the pivot model because indeed we find. So give you an example here. We actually notice, for example, it's kind of like, for example, if you fuse currently like a pairwise way, when you fuse, the different models, for example, like A and B model, and A, if you consider like the pivot model, and the B model is actually fused to A model. So in that sense, if B model is more challenging task, then the task, your performance probably failed. For example, like math is probably more challenging for coding compared to coding because we already know like Codex, like 2 or 3 years ago, it's already a very successful production already, but currently still we haven't heard there's a like large language modeling for math yet. In production, right? So math, indeed, we've also noticed that when we do this fusion process, so large language modeling for math is actually harder if you convert in that way. But vice versa, if you actually fuse your coding, large language modeling for coding, fuse to large language modeling for math, that domain small language model, then it will be kind of a successful. But however, as what I just said, in the middle of next month, we'll release so-called one in or. So that means we do
Yeah.
not have to the so-called pivotal model because that's very hard and very sensitive as well. Yeah.
Yeah, because if we have to select 2 or 3 models and then train, and it's about how about your selection. But in the next month, you will release a paper. We can train our models.
Yeah, you can actually train simultaneously
Really
in one.
excited to read it. I wanted to know the strategy is very difficult, but yeah, but it's a good direction in the future, and it's a new paradigm.
Yeah, again, I welcome, everyone if you are interested in this direction. And indeed, myself, I believe it should be the direction for the future. So
Yeah,
if you guys are interested in, I really welcome. Yeah.
yeah. And another question from the chat box is about the thanks for the great talk and many insights on LM training. And what is difference between MOE and the paradigm of model
No,
over
that's a very
model.
good question because people always ask this question. Okay, so MOE is actually a basic model backbone for the large language models. For example, it can be our domain specific small language model can also be MOE. So it's like a model backbone component. But however, MOM is a machine learning paradigm. It's the way how you train your parameters. So it's different thing from different granularities. Yes.
Okay, so that means MO is just we have used different backbone, but MOM we have the to train the
The
different.
way how to train your parameters.
Yeah,
Yes.
yeah, yeah. It's the difference. Yeah, no more. Anybody has questions? I think the Professor Young's talk is really, really, really great, very great, and have a lot of the insights. Actually, honestly speaking, it's my first time know that model over model, and actually it to solve our questions about in the next step how to merge models in medical data, something like that. Very, very good.
Okay, cool. Thanks for your invitation again. Yeah.
Yeah. So yeah, thank you so much today. Yeah.
Okay, bye.
Yeah. Yeah. Bye bye. Bye bye. Thank you all of you join our seminar. And in the next week, I will have a new seminar and hope you come here again. Thank you all of you. Bye bye.